In this class, we will learn about software problem solving, algorithm complexity, bit operations, number bases, and floating point number. Through this chapter, we will be able to explain the meaning of software problem solving capability, how to improve the capability, the necessity of algorithms, and the time complexity, which is a method for measuring the performance of algorithms. Also, we will learn about the bit operations and expressions frequently used. Furthermore, we will be able to explain various number systems and how to convert them, and the expression and characteristics of floating point number in a computer. Software problem solving. U.S. President Obama released a speech with the title, "I Want to All Americans to Learn Coding," to celebrate the Computer Science Education Week in September 2013 through YouTube. In this speech, President Obama mentioned, "Learning coding isn't just important for your future, it's important for American future." In addition, important people in the IT industry of the U.S., including Bill Gates, bring up the coding education. Currently, some nations like Finland, Estonia, and Vietnam give or introduce early coding education. Korean government caused controversy after Ministry of Science, ICT, and Future Planning said it would strengthen software education, including coding education. As there are pro-con debates on do all people need to learn about coding, the clear thing is the necessity and demand of coding education will increase continuously. Bruce Eccles said, "The differences in the productivities between programming skilled and those unskilled are up to 20 times. For programming to software development, we need to know much information. First, basically we should know the programming languages and libraries used for software development, and the knowledge on hardware and operating system on which programs operate. In addition, we need to know the maximum memory that can be used by a program. Furthermore, we should consider various user requirements, like the limitation in the user response time and the use of simple codes with high reusability." Programmers create programs by using different languages and tools under various environments. Thus, it is hard to evaluate the capacity of programmers under different conditions. Software problem-solving capability is the capacity to understand many limitations and requirements for programming and find out the best method. It is the capability of drawing big pictures by connecting the knowledge on the language or library, data structure, and algorithms used by programmers in the same way of placing puzzles at the right place. Program-solving capability is an abstract technology. There is no explicit definition like programming languages and algorithms, and the capability is not improved just by memorizing algorithms and solving many problems. Thus, to enhance problem-solving capacity, trainings are needed. For training problem-solving capabilities, it is not sufficient to learn about some new languages, frameworks, and development methodologies. It is required to learn the method of combining them, which is not so easy. It is vaguely guessed that the capability will be improved with experiences. However, the situations that can help develop the problem-solving experience are not frequently given, and it is not easy to develop the capabilities in that situation. So, the situations should be given artificially for training. Trains for developing the capability of problem-solving are needed by providing fairly chosen abstract problems and solving the problems. It is the problem-solving procedure. First, read a problem carefully to understand the problem. In this process, redefine the problem in familiar terms and arrange conditions to consider. After understanding the problem briefly, establish a plan and validate the plan how the problem-solving method can find a solution by using the examples used in problem description. After the validation, implement the program to test. Review the process of solving the problem and find, if any, improvement. It is good to read a problem and intuitively find a solution. But for most cases, it is hard to find a solution. Thus, setting a strategy of solving a problem needs systematic approach. For the systematic approach to a problem, it is helpful to think about the answers of the next questions. First, have you ever solved similar problems? Similar questions may have similar solutions. Second, can it begin from a simple method? In case of difficult problems, start with a simple method. Third, can the problem be simplified? Can it be represented as pictures? Can it be expressed in mathematical formula? Simplify a complex problem and find its solution. Fourth, can the problem be divided? Solving a small problem can solve a larger problem. Fifth, can the problem be solved by thinking backward from the back end? Read data backward and solve a problem. Finally, let's think about can specific form of answers be considered.